What are the colors we have made? Red, blue, green. Yellow, gray. Not gate. We'll use different colors. Huh? It will be easy for you, that one. Okay, what is this? This called like a not gate, not. Or it is called as a negation, or it's called as a complement. So what is this? What is this operation? It's called like a, what is the not operation? Is also called as negation or complement. What do you mean by complement? Negation of that. Zero means will become one, means how the input will be. If input is low, output will be high. Output will be, if input is high, output will be low. Negation, no? I don't think negatively, we say like this. I don't think negatively, means when you think ulta, complement, it's called like a complement or called like a negation or not operation. That one. How do we implement? We take help of transistor. So I think you know enough of some idea of the about the transistor. Like we have, this is a collector, base, emitter. So I started like this. So what is a high connected? A equal to logic 1, because A equal to 5 volt, no? Here 5 volt we applied at this particular thing. I'm explaining the one, logic 1. Let me give the input logic 1. So let's check the output. What do we get output here? Output or we see that one. Okay, let's write the loop equation. This is what 5 volt. Shall I begin like this? This is a cell VBB. This is a VCC. Sir, where is the cell? I'm not seeing here. Only dot. Okay, this positive terminal of cell is here. Negative terminal will be connected. So the circuit will become very big. That's why we are showing it like this here. Okay, let's come for this one. The implementation here, current IB will flow. Here VBE plus or minus. Here current IC will flow. Let's write loop equation. KVL, VBB plus VBB minus IBRB minus VB equal to 0. Okay, we have this is 5 high B 45 into 10 to the power of 3 or okay, this one here 0 0.5, 4.5 by 45. This will be milliampere. Let me write one more step. Anybody value of this? 45, 10 milliampere or 0.1 milliampere, I think. Yeah. Okay, this is the value of IB. He has given beta. We know IC is equal to no 100. Yeah, 100 into 0.1 into 10 to the power of minus 3. This will be 10 milliampere. Let's calculate V naught. V naught or VC both are same. Am I right? Okay, let's do one thing. This is also equal to VC. Let's write loop equation. Plus VCC minus ICRC minus VC equal to 0. VCC 5, IC 10 into 10 to the power of minus 3. This is a 5 kilo ohm. 5 or 0.5. 0.1 correct, no? I think I'm, yeah, this will be correct. 5 into, how much you are getting? 0.5, no? It is, yeah. Now look at how much VC we are getting. 0 volt or nothing but so what is the logic? When the input is high, output we are getting 1. Output, sorry, 0. Input A is 1. Here I'm getting logic 0. So how much we got it VC? 0. I think that you have to make observation of the end answer here. Sir, how do I got VC 0? That's what I wanted, no? And if VC 0, V naught 0 means 0 volt means what? Logic 0. So what we have tested for this one, no? When A is high, output Y will be low, that one. So what is A? A is input, Y is output here. So I think the first case, very first case, we have verified it. What we have verified? A equal to 1, Y equal to 0. Okay, let's see the other case. If A equal to 0, 0 means what happened? I should hurt it, no? Okay, let's see. If I hurt it, what we get it? Same circuit. So what is our, oh. Let's come for this one. So what is the next case for A0? Y will be 1. This we are checking. So this earlier we have started with this. Now we are checking this one here. So A0 means what shall I do? I should make this as earthing. I should earth it. And definitely what will happen? No current will flow. So just leave this part. In any current will flow here. If IB 0, IC must be 0. Huh? Sir, how it is? But cell is there. Okay, come for this formula. Look at this. If IB is 0, look at this one. If IB is 0, then what happens? Beta will be non-zero anyway. For any transition, is non-zero. So IC will be 0. So no current flows here. I think I adjusted everything. Okay, let's see what will happen now. What will happen to V naught? So what is the logic 0 is what we have brought it. Logic 0. What happened to Y? Okay, let's write loop equation now. Plus VCC 5 volt minus ICRC minus VC equal 0. What is VCC? 5 volt. IC is 0. 0 into RC. So VC I got 5 volt. So nothing but what pen? This is V naught, no? So what does it mean? Logic 1 or logic 0 there? Logic 1 will come. Is it okay? No, that not operation. Input is low, output will be high. Output is high. So how to interpret? If input is low, input is low, output is high. Input is high, output will be low. So shall I say it's like it will make ulta or say negation. We call that as in Boolean algebra. We call negation. In digital electronics, what we are studying is digital electronics. This is called like a complement. Complement of. So then therefore, how to represent this in Boolean algebra? We say a complement. That if you write some bar on it, no, it's not a vector a bar. No, not a vector here. A complement. Negation of that. If a equal to 0, complement of logic 0 is 1. Complement of logic 1 is logic 0. So somewhere we have to put that statement. Complement of logic 0 is logic 1 and vice versa. Okay, so these are the basic operation. These are all the basic operations. Okay, now we'll focus on further mathematical operations. So that's called like a Boolean algebra. So we'll introduce a systematically one. Now we know most of the basic operations. With the help of this, we will develop a algebra, a new mathematics called like a Boolean algebra. So the what is a Boolean algebra? So the math involved with the logical operations is called like a Boolean algebra. That one. What is that Boolean algebra? What are the basic things? So I'll start with the first one. A dot B is equal to B dot A.